Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Syazwana Binti Turiman, metric number AN190148. I'm a student of Bachelor Civil Engineering Technology Construction BNC. My supervisor is Prof. Nadia P.S. Suraya Hani Binti Adani. I will present my project report of Bachelor Degree Project 1, and my title is about the effect of Sago fine waste as replacements of cement bricks properties. The overview of my presentations involves the Chapter 1, Introduction, followed with a Chapter 2, Literature Review, and then Chapter 3, Methodology, the last one, Chapter 4, Expected Outcomes. Starts with Chapter 1, Introduction, for the background of study. The ever-increasing population and urbanization in Malaysia have led to the growing demand for construction materials. More manufacturing generates more waste, and more waste raises environmental concerns about harmful trades. Therefore, due to sustainability awareness, researchers and construction industries are focusing on employing waste as a new construction material to seek an ideal method for sustainable issue in construction industry. Brick is one of the most important raw materials used in construction projects in Malaysia to fulfill their living needs due to the increasing population of people, which has led to the rise of the construction industry in Malaysia. By the way, cement brick is commonly used in building construction in Malaysia because cement bricks is less expensive than clay brick. Cement is one of the important raw materials in manufacture of brick. Due to the overcapacity in production, the situation resulted in significant price pressure. Other than that, excessive cement consumption has a negative influence on the environment. There are several major environmental impacts associated with the cement industry, including solid waste, wastewater, flue gas, and noise. Besides, the sago husk, also known as waste of the sago processing, is dumped in the riverbank and river stream. As an alternative, using this waste to replace cement in bricks aims to improve the environmental quality. In terms of cement replacement, SFW can be one of the replacements due to its low cost, environmental content, and also the availability of SFW qualities. The problem statements in this study are made based on all of these questions. There is a problem with brick production as manufacturers struggle to obtain the appropriate natural resources because of the problem of insufficient natural resources such as water and limestone from a natural environment. The cost of creating cement bricks increase as the cost of cement increase. Because of the high cost of cement in the construction industry, manufacturers seek alternative solutions to replace the cement. Other than that, excessive cement consumption also have a negative influence on the environment. So the emissions from cement manufacturing processes impact air quality and can pollute the environment. For example, cement facilities produce sulfur dioxide, nitrogen oxide, and carbon monoxide, all of which are linked to health issues and environmental harm. Besides that, during processing of sago, a large amount of leftover solid waste such as bark and hampas is generated, which is generally burned or washed into adjacent streams. Along with expanding sago starch demand, the sago starch sector is currently dealing with waste management issues that cause pollution and health risks. Due to the all problems occurred, this study is being carried out to evaluate the availability of SFW as a replacement for cement in bricks, hence decreasing the pollution and the cost of manufacturing brick using cement. Furthermore, the purpose of this research is to determine the efficiency of employing SFW as a cement alternative. and also investigate the properties of cement bricks. The objective of this study, there are two objectives. First, to determine the compressive strength of bricks containing Sago fine waste as replacement for cement by doing a compression strength test. For the second objective, to investigate the physical properties of bricks by doing the density and initial rate of absorption test. For the scope of work, the goal of this study is to determine whether waste material which SFW may be used to partially replace cement bricks in the manufacturing process. The total specimens that are going testing in this study are 108 bricks, and then the mixed ratio of cement and sand is 1:3, with water cement ratio fixed at 0.6. The scope of this research covers the material characteristics, specimen preparations, and also the test methods. For the material characteristics, the SFW will be obtained from the supplier at Mukah, Sarawak, and the other aggregate materials such as cement and sand will be collected locally at laboratory of UTHM. For the specimen preparations, the curing process involves for about 7, 28, and 56 days. And for the percentage of SFW that replace the cement are 0% as a control, 1%, 3%, 5%, 7%, and also 9%. And the test methods that will be conducted in this study are compressive strength test, density test, and initial rate of absorption test. For significance of this study, in this study, a new alternative strategy for reducing this problem is to use Sago fine waste (SFW) in the production of construction materials such as brick, because SFW is a cheap and readily available resource, and SFW also may have an impact on the availability and strength of these cement bricks. Other than that, SFW also will help to conserve the natural resources and keep the environment clean. Move on to the chapter 2, literature review. In general, research revealed that Sago waste has the potential to be employed potentially as a replacement material for construction materials. The capacity of SFW as a replacement for brick manufacture is demonstrated in this study. So the density, water absorption, inertial rate of absorption, and also compressive strength are examples of properties investigated and discussed by researchers. The engineering properties or qualities of the bricks will be affected in terms of compressive strength, density, and initial rate of absorption once the waste material such as Sago waste incorporated in the manufacturing of brick. For the compressive strength, additional material added includes waste material as an additive impact the compressive strength of the bricks. For the density, there are several factors that will affect the density. For example, type of soil, the volume of water content, the percentage of waste, and also the type of waste incorporated. For the initial rate of absorption, the ability of the brick to absorb water also will affect the brick. Next, we look for the Sago fine waste as in the features. For example, Sago is a Japanese name for starch containing palm pith. Metroxylon Sago is the scientific name for this plant. Sarawak has the most Sago palm planting areas in Malaysia, especially in Mukah. The extraction of Sago starch from Sago trunks, which are washed, debugged, and rasped prior to the pulping process, produce Sago waste as a byproduct. Then the Sago waste will be released into the streams that can cause the pollution, which also cause the increasing of waste created. So SFW or Sago fine waste is produced during the extraction process after most of the starch has been taken from the respective of the Sago palm. Let's look to the processing of the Sago. The method of processing sago is very traditional and takes a long time, and the figure shows the summary of the processing sago. The processing of sago starts with cut sago logs after the sago palms are felled, right after planting and flowering, but before the fruiting. Cut sago logs are joined together in rafts and towed by boats to the sago factories for processing. During processing, the palm's bark layer is removed first, followed by maceration with a rasper. The rasping technique is done either manually or mechanically to crush the pith and free the starch particles within the fiber. The starch is then extracted from the fiber by kneading, trampling, or spraying with water. The starch is next put to a succession of centrifugal sieves to remove the coarse fibers. It is then removed by cyclone separators and dried with a rotary drum dryer, followed by hot air drying. So that's all for the summary of processing of the sago. Next, for the previous study of brick, several researchers have investigated the use of sago waste or sago husk in the production of bricks. Based on the summary of the previous work, these three authors used the differences of volume sago waste, water cement ratio, and also the test involved. To summarize, the results shows that the existence of sago waste in bricks as replacements will decrease the strength, decrease the density, and also increase the water absorption, but they still meet the requirement of standards. Next, focusing on the overview of sand-cement ratio, this section analyzes the previous researchers' decision of SFW concentration and water cement ratio. For the selection of SFW replacements, the additional percentage of SFW in bricks will influence the physical and properties of bricks. For overall, the result shows the increasing of percentage SFW as material replacement in manufacturing brick will decrease the strength, density, and initial rate of absorption, but increase the water absorption of bricks. Okay, for the selection of water cement ratio, the water cement ratio is the most important component in influencing the strength and workability of bricks. Based on the findings with different authors, the water content 0.5 and below is better for replacing sand that using waste such as RCA, PET, and HDPE. But different cases with SFW, the selection of water cement ratio for additives SFW is 0.6 much better due to the properties of sago fine waste that the water absorption is high to replace cement in manufacturing cement bricks. Move to the chapter 3, methodology. Alright, before beginning the experimental work, this study conducted a literature review and methodology such as sample collecting, material preparation, and material categorization. Waste material and raw materials will be involved in the initial stage of material preparation. In this study, the waste material that will be used is sago fine waste, which is SFW. Following with that, the materials will be tested using sieve analysis, bulk density, and also specific gravity. In this study, materials will be prepared using water, cement, sand, and SFW. However, the second stage of this study entails brick preparation, which will involve the mixture preparation by manually mixing the brick, and the samples will be molded using brick mold. The samples will be cast and cured before being prepared for various tests to examine the physical properties. This test includes compressive strength, density, and initial rate of absorption. The expected outcomes of this study will be conducted based on the research, and finally the end of this study. So this is the summary of the methodology flowchart. Starts with material collection and preparation. In this investigation, the materials that will be used are cement, sand, water, and Sago fine waste. To keep all materials in good condition, they will be stored at room temperature, where all the materials will be stored and placed in an airtight storage at laboratory. So first is SFW. The Sago fine waste for this study will be obtained from a supplier of a Sago mill in Muka, Sarawak. So the figure shows the SFW that has been processed. Second materials is cement. The types of cement that will be used in this study is ordinary Portland cement. The cement will be obtained locally at the laboratory of UTHM and should properly stored to avoid being exposed to moisture and hardening before use. Third material is sand. Sand that will be used in the study is natural white sand, and it will be collected locally at the UTHM laboratory. And the last material is water. Only clean, transparent, and drinkable water should be used in the production of the bricks for this study. The testing materials that will be involved in this study are sieve analysis, specific gravity test, and also the bulk density test. For the sieve analysis is to determine the particle size distribution by using the mechanical sieve shaker. For the specific gravity test is to determine fine aggregate weight under 3 different sample conditions, which are oven dry, saturated surface dry, and submerged in water. For the bulk density is determined by the density with which the aggregate is packed. The condition of the sample for bulk density shall be made on oven dry or saturated surface dry materials. In this study, mold will be used. The brick dimensions are determined by referring to the British standards. As a result, the brick molds must be formed in accordance with the scales specified in Malaysia Standard 76 and British Standard 3921, which is 250 millimeter length, 102.5 millimeter width, and 65 millimeter height for 1 unit of normal bricks. So the figure below shows the example of brick mold that is made from the wood materials. For the design mix of proportion in this study, there are 3 main ingredients, which are cement, fine aggregates, and water, while the SFW as a waste material to replace the cement. The bricks will be molded with British standards dimensions. Sand-cement ratio of composite brick will be 1:3. The water-cement ratio will be 0.6. And the volume replacement material was 0% as a control, 1%, 3%, 5%, 7%, and 9% of SFW. Now focus to the preparation of mixtures. The tests that will be involved are 54 specimens for compressive strength and density, and 54 also for initial rate of absorption test. This means that there are 2 set samples that will be conducted. The name for SFW1 is meant by the volume of SFW is 1%. SFW3 means for the volume of SFW 3%, and so on. While the W0.6 means the water cement ratio is 0.6. So the total specimen that will be involved in this study are 100 egg bricks. The the brick preparation process, which starts with preparing the materials, and then the sand and cement will be poured to the tray, followed with added SFW that will be added to the mixtures. Next, half of wake water will be poured to the mixtures, and then the remain of water will be added. And the last one is mixture ready for pouring and casting. For the brick casting, it will involve casting the brick by pouring the mixtures into the mold in 3 layers, and then tamping the mixture with steel rod for about 25 times for each layer. Each specimen must be labeled with its mixture proportion and fabrication date for identification. The samples must then be left for 24 hours before being removed from the mold. For the curing, maintaining a suitable moisture content and temperature in samples for a suitable period of time. The bricks will be stored in the open air for 14 days at room temperature and allowed to cure for 56 days. After curing, samples are going to be prepared for the next testing. Talk about the laboratory testing. There are 3 testing that will be conducted in this study, which are compressive strain test, density test, and initial rate of absorption. For the compressive strain test, the test will be performed after 7, 28, and 56 days of cure. There are 54 samples, and it will be performed on 18 design mixers of bricks with 3 specimens for each mix for average data. It will be performed in the concrete laboratory at UTHM. So this is the formula for compressive strain test. The density test, a total of 54 samples will be evaluated at the ages of 7, 28, and 56 days. First, the sample will be dried and its weight will be determined. The drying and waking processes will be repeated. So this is the formula for the brick density. The last one is initial rate of absorption. This test will involve in the oven and then immersed in the water, and at last will wake the specimen. So the good rate of initial water absorption is between 0.25 to 2 kilogram per meter square minute. Last chapter in this study, which is chapter 4, expected outcomes. So for the overall of this study, if all the tests discussed pass, Sago fine waste or SFW can be used as a new material in the construction industry. And other expected is also SFW can be a replacement for cement in manufacturing of cement bricks instead of reducing the pollution in this world. Other than that, SFW also can be used in developing construction industry and effect to the cement brick properties in perspective of strength, weight, permeability, and others. So that's all from me. Thank you so much for hearing my video presentations.